Hello everyone, I'm Taslim Alon. Today I'll present an important topic, and that is the intrusion detection system using optimized deep machine learning. This research focuses on improving cybersecurity using advanced machine learning, deep learning, and explainable AI techniques. In this presentation, I will discuss why modern cybersecurity needs intelligent intrusion detection system, how machine learning and deep learning in improving attack detection, why explainable AI is important, the methodology and dataset use, the experimental result, and the finally future detection direction of this researches. Cybersecurity has become as one of the most important technological challenges of our time. Every organizations face millions of cyber attacks, including eh, malware phishing, denial service attack, ransom, and unauthorized access attempt. Traditional security systems are no longer enough because attackers continuously evolve their techniques. Therefore, intelligent AI-based security systems are now essential. This presentation explains how our purpose ideas framework address both performance and interpretable challenges in simultaneously. In our presentation outline is that now let me briefly discuss the structure of the presentation. This presentation is divided into the several technique part and the cybersecurity challenges. And then I will discuss the research gap and statement, and including dataset, machine learning models, and explainable AI techniques. Next comes one scope of and literature review where I compare studies related to idea system. Then I will explain proposed methodology step by step. Final following that I will present experimental result and performance analysis. Finally, I will conclude the presentation with future research detail and direction and reference. Let's begin with the background of the study. Digital world, cyber threats are increasing rapidly. Modern organizations they rely heavily on computer network, cloud system, IoT device, AI-enabled system, and online communication platforms. As digital dependency increases, cyber attacks also become more sophisticated. Attackers now Attackers now use automated tools, AI-based hacking techniques, and bonnets, large scale of bonnets to compromise the system. Because of this, organization requires continuous monitoring system that can identify suspicious activities in the real world. This is where intrusion detection system or IDS become extremely important, and IDS monitor the network traffic and detects malicious behavior or unauthorized access at a traditionally IDS system are rule-based system depends on the different a different signature of known attackers. However, the system faces serious limitations. For example, they cannot detect unknown or zero-day attacks that they require continuous manual rule update. They struggle with evolving attack patterns. To become this issue, researchers started using machine learning and deep learning. Machine learning models can learn pattern from large dataset and identify abnormal behavior automatically. Deep learning models can extract complex hidden patterns from network traffic data. This makes AI-powered IDS system far more effective than traditional approaches. However, AI-based IDS system introduced another major problem, the black box issue. And this is the black box issue. Many advanced AI models make highly accurate prediction, but humans can make mistakes and how those predictions are made. This lack of the transparency creates trust in issue in cybersecurity operations. Security analyst needs explanation before taking critical action. That's why explainable AI and XAI has become essential. Now let us discuss the explainability of problem in more details. Machine learning and deep learning models often behavior like black box AI. They provide predictions such as the connection is malicious or the traffic is normal, but uh, uh, but they do not explain why decision was made. This creates several practical problems. Firstly, security analysts can to verify whether whether models reasoning is correct. Secondly, organization may hesitate to deploy AI system in critical infrastructure because they can't trust explainable decision. Third, regulatory and compliance requirement increasingly demand transparency in AI system. This is where explainable AI become important in this research. We use to measure XI techniques, firstly SHAP and SHAP shape and LIME local Shapley additivity explanation, LIME local interpretable model, agnostic explanation. SHAP helps need identify a globally important feature across the entire model. Lime explains individually prediction locally. For example, if a connection is classified as an attacker's, Lime can show which feature contributed most to that decision. This improves transparency and build trust. The key insight here is high accuracy alone is not sufficient for real-world cybersecurity deployment, and effective ideas must not be interpretable and trustworthy. Now I will discuss the research gaps of identifies in existing studies. After reviewing previous research paper, we identify four major gaps. Firstly, gap one is the accuracy without explainability. Explainability. Most previous ideas research focus mainly on improving test classification accuracy. Very few studies addressed interpretability. How explainability is critical for real-world deployment. Without explanation, analysts may not trust all the AI patterns or laws. Secondly, limited cross-dataset validation. Many studies train and test models on the same dataset. This creates overfitting. This creates overfitting risk. AI model perform well on dataset may fail in another environment. Therefore, cross-dataset validation is necessary to verify crash and reliability. Thirdly, hyperparameter organization neglect. Many research use default parameters. However, optimized hyperparameters can significantly improve model performance. Systematic turning more methods such as grid search CV and random search CV are often ignored. And finally, absence of unidentified unified ML LDL Excel framework. Most studies evaluate only one or two models. Very few combine classical machine learning, deep learning, and explainable AI and find a comparative framework. Our research address all these limitations simultaneously. Now let us discuss the core problem statement. And the main problem is modern cyber threats. Modern cyber threats are increasingly complex, dynamic, and intelligent. Therefore, IDS system must not only achieve high detection accuracy but also provide transparency. And there are several specific challenges. High false provide an based IDS system classify normal behaviors that occur this while analyzing unnecessary attackers. Too many false alarms reduce operational efficiency. Secondly, data imbalance, normal traffic. In network traffic, normal data heavily outnumbers malicious. traffic. This creates a based bias data set, making model training inherently based on unreliable. And secondly, continuous simulation attackers many network environment continuously change. Attackers constantly deploy new techniques. Therefore, ITS model require continuous updating and training. And finally, trust transparency, security analysis needs explanation before trusting automated AI decision. Without explainability, AI deployment becomes risky and critical system. Our research attempts to solve these problems through one optimized explainable ideas framework. Now we'll discuss the scope of the research, and this study used to measure dataset, IDS Kaggle dataset, IDS Kaggle dataset in IDS Kaggle dataset models and XI methods. Ideal Kaggle dataset has 125,973 records and with 42 feature binary classification, and that is the normal attack by normal versus attackers. And attackers categories include DOS, probe, U2RG, and R2RG attacker types. NSLKD dataset. This dataset will use for cross data validation, and the model used. We have five models: random forest, XGBoost, XGBoost can nearest neighbors, decision tree, and LSTM for deep learning. Explainability and AI we use shape, live, and guard CCAM. Data splitting. The data set was divided into 70% of training, 50% of validation, and 50% of testing. We also certified K before cross validation, and K is level 5. This ensures balanced classifying class distribution across fault. Now let us review previous research studies. Several research achieved as strong ideas performance using AI technique. For example, Sadia et al. Also CNN. As I received in the research in 97% accuracy, particular 80 wall is 97.10% accuracy with SVM with an Chakraborty video acid 99% accuracy using LSTM neural net, along with wall stackers LSTM zero detection system, and context is the deep reinforcement learning framework. Roman 81 USDNN and RFI random forest and SVM models with 98.5% accuracy. These studies demonstrate the growing importance of AI intrusion detection. However, most focus primarily on performance metrics. Few studies emphasize explainability over broad dataset robust test. This motivates our researchers. Now let us discuss XI explainable AI related literature. Recent recent studies highlight the importance of explainable AI in cybersecurity. Researchers argue that explainability acts as bridge between AI system and human analyzed shape and line provide global becoming increasingly popular because they improve model transparency. However, several limitations still exist. Most previous works do not combine ML, DL, and XI to integrated framework, do not perform extensive cross-data set, and do not systematically optimized model hypermeter. Our research advances the field of integrating all these components into the unified framework. Now let's explain our methodology. The proposed framework contains several stages. Step 1, input data set. Step 1, introduction. Secondly, processing. Thirdly, feature engineering. Then fourth, model training, hypermeter training, cross validation, classification, and XAI and post data set. Now let us discuss processing the more detail. Data processing is extremely important because poor quality data leads to poor model performance. So we perform several processing steps: level encoding, categorical features such as protocol type are converted to numeric values using level encoder. Secondly, removing duplicate routers eliminated to prevent model bias and data leakage. Thirdly, missing value handling. Missing value are either removed or imported depending on feature importance, and finally feature and target separation. Feature was separated into X variable target levels were stored in Y. Proper processing significantly improved model reliability and training efficiency. Now we'll discuss the model used. Firstly, random forest is an ensemble learning method using multiple decision tree. It reduce overfitting and improve accuracy. Secondly, XGBoost is the gradient boost algorithm known for exceptional performance and speed. It handles structured data very effectively. KNN, that means the K nearest neighbors classifies database to on nearest neighbor example. It's simple but computationally expensive for large dataset. Decision tree provides interpretable rule-based in classification, however they may overfit if not controlled properly. LSTM is the deep learning uh, recurrent neural network designed for sequential data. It captures temporal pattern effectively. We optimize several LSTM hyperparameter and LSTM parameter is the LSTM units, density unit, importer and drop-off rate, learning rate, optimizer and train. Trains their hyperparameter tuning significantly improve model performance. Now let's discuss the explainable AI implementation. Shape calculates feature importance using game throw and theory concept. It measure how much each feature contributes to prediction. For example, SARS bytes, DST bytes, and log distance stars. SHA provides global interpretability and LIME local interpretable model of agnostic explanations. Suppose the model to predict network connection as malicious with 98% confidence. LIME identifies which feature pushed the prediction toward anomaly class. This helps analyze understand why the alert occurred. This makes the system a more transparent, interpretable, and trustworthy. And this is the methodology of XI diagram, and why I can see that classification and the shape and line. Now let us analyze of the result. AI model excellent performance on the IDS datasets XGBoost and random forest. Both achieved 99.5%, and decision tree achieved 99.38%. LISTM achieved 98.79%. This result demonstrates that both machine learning and deep learning models are highly effective in intrusion detection. Exhibits slightly outperformed other model overall. Qualitative validation is extremely important. A model that performs well on only one dataset may not realize well on the uh, NSL and KDD dataset. Exhibits Asif 98.62% accuracy, random forest 98.52 accuracy, 98.58 accuracy, LSTM ASIP 97.78% accuracy. One important observation that is the random forest experienced a record drop. This is suggests charm dependency. One data says characteristics, meanwhile boost to maintain balance, precision, recall, and F1 score. This demonstrates strong robustness and generalizability. And when the key observation executes to 98% accuracy and perfect balance precision, recall F1 or F1 shows random forest shows accuracy drop one lower recall 88.05% on ANSL GDD. That depends on the character dataset characteristic. Models trained one IDS dataset is still perform less than 97% on SLKDD demonstrate a strong generalizability. Now let us analyze LSTM performance on the dataset in one IDS dataset. Training accuracy is 99.51%, validation accuracy was 98.7%, that's training loss is 1.28%, and validation loss is 3.8%. This difference is small, this indicates minimal overfitting. One NSGL NSLKDD dataset training accuracy is 97.85% and the validation accuracy is 97.82%, and the training loss is 6.72% and the validation is 5.85%. Again, the values are very close, and this confirms system generalization capability. The higher validation loss on NSLK data suggests the data is more complex. Overall, the optimizing LSTM model performed very well. Here you can see the model go. This slide visually compares model performance echoes on dataset. We can see random forest, XGBoost, and KNN dataset, and data tree, and LSTM. And we can the blue mark is the IDS dataset, and the green mark is NSLKDD. We can clearly observe that exhibits constantly achieve their highest accuracy, followed close randomly forest with LSTM maintain competitive performance. The difference between model is relatively small, indicating that all approach are effective. However, exhibits demonstrate the best balance between performance and generalization. Now let us examine the explainability of result and shape analysis. Shape identifies the most important features: search byte, DST byte count, DST host name, source, port rate, DST host SRP count, logged in, and protocol type. High search byte and DST bytes often indicate malicious behavior. Meanwhile, logged in status strongly indicate normal behavior. And line local prediction explanation. A line explained individual prediction, for example, failed login item, unusual byte counts, and abnormal protocol behavior contribute to anomaly detection. This explanation validation that the model is learning meaningful security patterns rather than random corrections. This is extremely important for real-world deployment. Now let us compare our work with previous studies. Previous method achieved accuracies between 97% and 98%, 98.52%. This outperformed well. This outperformed all cited state of the art approaches. The result demonstrates that our optimized and explainable framework provides superior performance. Additionally, our framework includes explainability and cross dataset validation, which many previous works lacked. Now we will conclude the presentation. This research successfully developed an integrated ideas framework combining machine learning, deep learning, and explainable AI. The framework achieved outstanding detection accuracy while maintaining interpretability, and the Parvis performance is exhibits 99.52% accuracy, IDS and 98.62% NSLKDD, and the top performance across all matrices. The framework achieved outstanding detection accuracy and while maintaining interpretability. Major contribution is the X Ghost is the safe to best overall performance. LSTM demonstrated strong deep learning capability with minimal overfitting, cross dataset validation, confirmed generalization, confirmed strong robustness, and world models maintaining less than 97% accuracy, providing robustness to big undefined data, shape Chef and Lime improve transparency, analyze just the framework support practical deployment in real cybersecurity environment. Overall, this research bridges the gap between high-performance AI just this cybersecurity system. There are several possible future research detection in firstly real-time deployment, real-time maintenance deployment, integrating on the framework with like network monitoring infrastructure to the test performance under real world traffic condition with streaming data pipelines. Secondly, transformers and attention model explore transformers architecture and self-attention mechanism, which may outperform LSTM for complex temporal network traffic patterns. Thirdly, federated learning, enabling distributed training without sharing sensitive data. Fourthly, adversarial robustness testing, evaluate and harden model performance against adversarial machine learning attacks that aim to evade intrusion of detection system. Fifthly, multi-class attack and classification extend from binary normal attack or binary attack. That's fine and grained multi-class function classification to identify specific attack type and DOS, GDWOS, probe, R2L, and multi. And advanced explainability using additional explainable AI methods such as integrated system, integrated gradients, counterfactual explanation, and attention visualization. This detection can further improve ideas effectiveness and trustworthiness. Here we can see some reference on our intrusion detection system for computer network security system, and the slides contain reference used in this research, and the reference include IEEE paper, journal articles, and conferences, publication, Kaggle dataset, and cybersecurity surveys. They provide the theoretical foundation and comparative baseline for this study. Thank you for attention. I hope this presentation provide a clear understanding how machine learning and deep learning and explainable AI can improve intrusion detection system. I would now be happy to answer any question or discussion in any part of the research. And thank you. And if you have any question, you can't. If you have any question, you can comment. You can comment it below, and I will answer you immediately.